Good evening, everyone, and welcome. I want to start by asking a few questions. Have you ever wondered how your bank instantly flags a potential fraudulent transaction, or why does the price of an airline's change every time you visit their website? Maybe from one browser you visit, you see a price. Using a different person's phone, different person's device, you see a different price. These just aren't clever tricks. These are smart, real-time applications of the concept that we are going to talk about today. That is data, data professionals, and the AI systems built within it. So before we dive into specific roles and what these things are about, let me give you a small an idea about the terms that we usually come across in the world of data, but people are usually confused about that. So let's start with the first and most important thing, data. Now, what is data? That's a very legit question, right? What is data? Data is just raw facts and figures. It can be text, it can be image, it can be video, it can be a GPS location, it can be anything. So anything that is raw facts and figures that's not organized, that's not arranged properly, that's data in the digital world. Artificial intelligence, on the other hand, is a broad field dedicated to making machines perform tasks that would typically require human intelligence. Now, it's very important over here. Key distinction from artificial intelligence with any other systems is it can do tasks that humans could do using their intelligence. So, in other words, any intelligent machine that is capable of making its own decisions based on some models, based on some data, that is artificial intelligence. Now, let's say, just to give you an example, let's say ChatGPT, chatbot, right? When you are talking to ChatGPT or Gemini or Grok or any other chatbot out there, you are talking in your own language, and it's understanding your language and translating it into something that computer can understand, and eventually it can get the task done that is appointed to it in a human language. If there was no artificial intelligence, if the chatbots didn't exist, what would you have to do? You would have had to, let's say you wanted to create a data analytics project, you would have had to go ahead, clean the data yourself, make your decisions, and based on your decisions you will have to write the code. AI systems can do all that independently without any human interventions. Now, something to remember over here is when I said they can do this independently, well, that's the idea that's called artificial general intelligence, but we don't want to go into much discussion about that. But that's the whole idea of artificial intelligence, or where people want this system to go. But in today's day and age, we do not have a true artificial general intelligence, but we are pretty close to that. Now, another important term that you come across in the world of AI and data nowadays is machine learning. So machine learning is a subfield where computers learn from patterns without being explicitly told what to do. Sounds familiar, right? Sounds like artificial intelligence. You're right. Machine learning is the basis of an artificial intelligence. Artificial intelligence is nothing, the chatbots and everything that we see, it's nothing but a model that's trained on huge data sets. That's it. If you have a model that can be trained on a lot of data and it can perform a lot of tasks together, in layman terms, that is artificial intelligence for you. And finally, what is data science? Data science is the professional discipline of using data and these machine learning and AI techniques to find hidden insights and make predictions. Remember, it's very important. In the world of data science, it's very important to recognize a pattern and based on that pattern, make a prediction as accurately as possible. Is the engine that powers the modern business world. For decades, business decisions were based on intuition, experience, and historical trends that were analyzed manually, or that experience lied within one individual. I had a boss who could, he never worked in analytics, or he never worked in that field, but he had experience of working as a department heads. And from his experience, just by looking at numbers, just by looking at data, he could exactly, wouldn't be predict things, but he could say where things were going. So there was this one time when I made a mistake in my report, and I was talking to my department head, and my eyes couldn't see the mistake, but whenever he saw the numbers, he was like, hey, something seems off over here, can you go and check? And when I rechecked it, and guess what, he was correct. So he, without knowing analytics, without knowing everything, from his experience, he could tell that something was wrong. So this experience, this kind of pattern recognition comes when this is installed in a machine. That's where we get artificial intelligence. That's where we get data driven decision making. Today the uh, today the mindset of a revolution. So today we are in the mindset of a revolution where data is no longer a byproduct of operations. It's the most valuable asset to a company. We are shifting from a world of gut feelings to a world driven by data, to be exact, quantifiable data. This isn't just an upgrade. This is a fundamental transformation of how business create value. This kind of fundamental transformation comes only in decades, and we are witnessing that fundamental transformation of how businesses work. Now that we are aware of the basic terms that come across the field when we talk about data science and all those things, there are also 4 roles that we come up with. We actually hear a lot about, that is data analyst, data engineer, data scientist, and AI engineer. Now on the screen you can see a small description of what these roles do. So let's go through them, and we will also do a real life business case in today's session, so that you can have a better idea about these roles and how our entire process fits together in a system. Now it is very important to remember, in this day and age, it's very important to be a systems thinker. You cannot think independently as, well, I only do the data pipelining, I don't care what happens after that. Your value is diminished through that kind of thinking. The way you can increase your value is do a system thinking where everything fits together in the system. So we will see an example on that, but before that, let's look at individual roles and see what they're about. Now data analyst, it's like a digital detective, right? So let's say you have a crime scene and a police arrives in the scene. So detectives come in, they look at the symptoms, they look at the all those clues left behind by the perpetrator, and they try to figure out what's going on. They try to create a story, and they try to come up with the evidence to support that story. A data analyst does exactly the same thing. He finds patterns in historical data to understand the current business scenario, and through the patterns, through those understandings, he delivers insights through his dashboards and reports. Next role we are going to look into is data engineer, the digital plumber. Now this person focuses on the data infrastructure and pipelines. So this person, a data engineer, he builds and maintains system to collect, store, process data at a scale. It's very important to remember, at a scale. We all do some level of data maintenance, data collection, and data storing, but we all are not data engineers because our work cannot be scaled. It's very important that the work of a data engineer can be scaled. And of course, he has to ensure that all the data that he's collecting is clean and available for others, especially data scientists, data analysts, or AI engineer, to make use of that numbers, make use of those reports. The data scientist, he is like the strategist. So he is more focused on predictive modeling and insight generation. So he uses statistics and other machine learning tools to find patterns and focus on the future. So he is going to say that, hey, we are expecting a huge surge in, let's say you have a coffee shop and you're at the summer is starting, and a data analyst, a data scientist will say that, hey, we are expecting a huge surge of coffee sale in the next month. Please make sure all your equipments are updated and ensure that you have enough number of staffs to serve the increased demand. So he is setting up a strategy for the company that, hey, we need to start hiring people so that we have sufficient staffs when the demand increases. And finally, we have AI engineer, the person who focuses on deployment and scalability. So he transforms prototypes into automated real-time systems. He optimizes models to run efficiently in production. It's very important. So data engineer ensures that data is being stored and processed properly. Data scientist is strategizing on the future, and data analyst is finding insights from those numbers. They are trying to find patterns and tell a story. Data engineer is trying to ensure that the work of all these things stands together in one single system and everything performs well as one unified system. Over here you can see that I have created basically a intersection of data science, data engineer, data scientist, data analyst, right? So as you can see, as a data analyst, you need to have a lot of business acumen, a little bit of data cleaning, and a little bit of programming. A data engineer has to ensure that he knows programming, he knows data wrangling. Data wrangling is the formal term for data cleaning. What do we mean by data cleaning? Well, data usually don't come up in clean formats, so we need to, as a data scientist or analyst, we need to ensure that all our data is clean and ready to be used for further analytics or ready to be implemented in a machine learning model. And in order to do that, we do data wrangling or data cleaning. And as a data scientist, as you can see, he is much focused on statistical modeling, because it's the statistical modeling that allows him to predict the future. And finally, an AI engineer, he has knowledge about data cleaning, scalability, programming, business, statistical modeling. So he is the jack of all trades. He ensures that everything else performs nicely and in a altogether synchronized format. Now let's look at the business example that we were talking about. Now let's say we are talking about customer churn. So what do I mean by customer churn? That is customers dropping from any subscription based business, right? Like streaming service, like Netflix. So it costs company far more to acquire a new customer than to keep an existing one. The whole object is to reduce churn and increase customer lifetime value. CLV, it's very important. Customer lifetime value. In the world of business, people try to increase the customer lifetime value, and that's how we ensure that most of our most of our customers are giving us the highest profit that we could extract. Now that the case is explained, so we are trying to ensure that our customers churn rate is reduced. Let's look at a glimpse of Macy data. So the data engineer acts as a digital plumber, right? I have told that before. So building infrastructures to collect and clean raw and messy data. Their work is the foundational step for every project. That's the official definition. So let's say we have a JSON data that looks like this, as you can see on the screen. And he is going to ensure that over here payment status is pending. So he is going to ensure that if the payment status is pending, and whenever the payment status is updated, although this data flows through the pipeline, the updated data is also going through the pipeline. Imagine a scenario: you are working at a bank and you made a payment at a POS transaction, and it takes some time to for the approval to go through, right? So what if you made the transaction, it was showing pending transaction, and the data never flowed to the bank from the point of sale? Although it will register as a transaction, but your account balance will not be reduced. So you will have unlimited access to money, right? So mistake in creating a data pipeline can cost huge, can be a very, very expensive mistake for any business. That is why data engineers need to be very sincere. They get paid so much money in the market. Now, once the pipeline is created, all right, once we know all how information about all our customers, remember our focus was retaining customers, reducing customer churn rates. Now, once that data becomes available, a data analyst looks into that data and says, in the last 3 months, 80% users logged in, but 20% of the people never logged into our system. Now, what's going on with this 20% of these people? Something to be concerned about, right? So a data analyst finds these key findings. I mean, there could be other findings, but this is just a sample that we are using. So he provides this information to someone else in the team. The data scientist or the strategist, using the data and insights, they build a predictive model to forecast what will happen next. So in our case, they calculate a churn score to predict which customers are at risk. So when data analyst figured out that okay, 20% of the customers never logged in, maybe data scientist says, okay, let's focus on this 20% customer first, and then let's see what's happening with the 80%. So he developed a model to predict the probability of customer leaving our business. He incorporated maybe his login behavior, his spending pattern, his watching pattern, a lot of things, whatever the things that he decided are important, he incorporated them into a model, and he confidently said that, well, each customer has a certain percentage of chances of dropping our subscription. Imagine you running a business and you know when your customers are gonna leave you, at what point they're going to leave you. This gives you a lot of power, right? You can take steps to convince that customer to stay with you. You can take steps so that the customer never leaves. It will not only increase your revenue, it will save you a lot of cost, because acquiring a new customer is more expensive than retaining your existing customers. Now, the final step is AI engineer takes the predictive model and integrates into a live automated system. Then their system is connected with maybe automated messaging systems that is developed by the marketing team, or maybe some other strategies that's been developed by some other team, and he ensures that all those predictions, all those numbers gets incorporated in system, and as per the plan of the marketing or whoever that person team is making the plan, it could be the AI engineer himself, to send targeted message to those customers, or give them a discount on their subscriptions, or do something else and convince them to stay with our business, not cancel our subscription. So what's happening over here is, finally, the job of an AI engineer is that you need to reduce my customer churn rate. So in the first quarter of this year, we had 25 people leaving our business. In the second quarter, AI engineer, using the strategies developed, were successfully able to reduce the number by 5. In the third, it was down to 15, and finally only 12 customers left in the final quarter. So as you can see, there is a gradual decrease in customer churn rates because of all the steps and all the activities done by this data analysts, data scientists, and of course AI engineers. So finally, what we have is what I wanted to talk about, and what I want you guys to know is, it's a continuous value cycle. Most AI systems don't just exist, they evolve, because data is continuous feedback loop, making the model smarter over time. So what I'm essentially telling you is, all these customer churn rates, all these attempts, it will not be successful. It could be successful in one go, but it will be more and more successful once you keep on repeating this process. So it's very important to repeat this process. As you can see on the screen, I have created a basic version of how this works. So the data comes in, the model, it's installed into the model, it's fitted into a model, and the model is trained. And based on that training, the model gives us some predictions, and we use those predictions to make some real life changes in the automated system. And once the automated system makes those changes, again we have a new set of data, right? How did a customer react to a targeted message? How did a customer react to a discounted subscription rate? How did a customer react to having three free coffees every month if he spend $50 in purchases with your store, right? All these kind of offers you need to evaluate, and of course all kinds of offers will not be valuable, right? You will see that some strategies are working like magic, that's helping customers stay, and you will also see some strategies are not working the way they were supposed to, because there can be many factors, and humans, at the end of the day, nobody can predict human behavior 100% accurately, right? So in order to make your model better, you always need to keep in retraining the models with the updated data and try to be as accurate as possible. Remember, it's very important for us to be as accurate as possible, and the only way we can do this is through a continuous value cycle. Talking about all these things, what's important over here to understand is that as you have heard that I have been talking a lot about data science and AI engineers and AI and data together, and you are right to mark this point, because systems, AI, data science, they work together. AI is nothing but a system that's trained on data, correct? So this is what we call foundational models and the frontier models. So long back, there was like a system where people said like, hey, we have the hardware capabilities, we have all the resources, let's do one thing. Instead of training my models on one specific data, let's say I am training my machine to predict the circuit failures in the electric grid system. Instead of doing that, let's train that model with everything that's out there in the internet, starting from how to prepare for your SATs or GREs, or how to do a data science project, to, of course, predicting when your electric signal system is going to fail. So all these kind of things, they work together into one unified system. So as in the modern day and age, what I would suggest you to do is, instead of thinking data, AI as two separate things, think them as two sides of the same coin. AI needs data. AI cannot function without proper cleaned data. It's very simple. The better models, the better the quality of data, the better the models will get. Plain and simple. So imagine all the latest release that's coming from those foundational models like ChatGPT, frontier models nowadays, the Gemini. They are just finding new ways to train their models so that they can respond better to the customers' queries. They can respond better to the users, uh, users' queries and users. Yeah, as a matter of fact, some models are trained to respond to users' emotions, right? So people are continuously training these systems and continuously improving, and that's what you should keep in mind as a technology professional, as a data professional. There should be the habit of continuous learning and continuous development. If you stop your continuous learning, and if you stop continuous development, if you stop the loop, your system is going to become obsolete very soon. Not only will your system become obsolete, your knowledge will become obsolete, and you will struggle to stay relevant in the market. Thank you all. That's it for today's course. See you for the next session.